Hi from Paris, sitting outside. Hopefully you can see the nice terrace behind me. Dr. Wieland has to suffer through another one of my reviews because he listened to one from Tuesday, which I just recorded. So it's a lovely 40 degrees out, which I think is awesome. This one was in my lap, which is nice and white, and this one is sitting outside in the cold, which is on the verge of frost. Just kidding, it's refreshing because Florida's already getting hot. Okay, so, you have an in-class activity for today, and I think that with the self-guided review, that will get you pretty much through everything you need to know so that you can think like I think and diagnose and have the critical thinking skills that separate you from the rest of the world because they don't know how to read blood and analyze the body. So I challenge you to this task, and I know you all can do it. I'm really proud of you, and thanks for hanging in there, especially while I'm gone. So I hope you enjoy the in-class activity, and we're going to power through a little bit of a review. I'm not going to spend a lot of time going through stuff, just some of the big points. I think that this will pair really nicely with your in-class activity, and I'm sure by now if you did some of the self-guided review, you're already on top of it anyways. The exam will have 2 CBCs to analyze in entirety with the white blood cell, red blood cell portion, the full CBC with differential. And it's going to be the basics. If you know the basics, I'm not going to give you I don't expect you to analyze a complex case. Some of the ones we looked at, because those were my real files, those are real bodies. And of course, real bodies sitting in front of you, people who have biochemical derangements, they don't follow the rules. So you have to be able to know you have to follow patterns so that you can start to differentiate why is this happening, what could be presenting with that, because it's literally a Rubik's Cube jigsaw puzzle. But you have to remember, and I challenge the diet and nutrition, the biochem, who also they have me for both classes. This isn't just memorizing annoying material to take a test. This is an individual you are learning to diagnose and to treat, and they are scared, they have symptoms, and they're sitting in front of you, and they are depending on you. And they've gone to so many different doctors and offices, and majority of the time, doctors shop for years before they find one of us, normally a chiropractor, and I'm being arrogant because we have a wonderful reputation for helping find the problem after they've suffered for years unsuccessfully in the real world, right? So I hope you have enjoyed this material and have a little bit of a different perspective on how we analyze this and what's going on. Okay, so obviously I've really driven home when you're analyzing MCV for size, right? Is it too big or is it too small? That is not anemia. You absolutely have to remember that only the index, RBC count on the CBC is diagnostic for anemia. Anemia is not enough red blood cells circulating. End of story. But what does that also mean? If you don't have enough red blood cells circulating, you're either going to have too much blood loss or you're going to have failed erythropoiesis. Be sure you know the difference between erythropoiesis, which is the synthesis of red blood cells in the bone marrow, versus hematopoiesis, which is the bone marrow pumping out all of the cellular contents. That would be white blood cells, platelets, as well as your RBCs. So erythropoiesis is specifically the RBC synthesis. Now, most of the time, we're going to have the low count, right, in anemia, which is going to be almost more likely your hemolytic, right? That's going to be the red blood cells dying in circulation, not being eaten, phagocytosed by the spleen's macrophages, or we're going to have excessive blood loss. And almost always, that's going to be a gastric bleed or a female menstruation that is too heavy, too often, not balanced by the bone marrow's ability to keep up. Okay, so when we have all of these macrocytosis and microcytosis occurring without the anemias, almost always that's going to be your nutritional deficiencies. That means that the precursors are not bioavailable. So if you have a nutritional deficiency or insufficiency, a deficiency is an outright not available. An insufficiency could mean that your body has a higher demand. If you are in a higher altitude, you need to be making more red blood cells. If you are hypoxic because you have asthma, you have to be making more red blood cells. If you are menstruating every 3 weeks and you're clotting and you're losing too much blood, then you are synthesizing and you need more precursors to keep up. So erythropoiesis in that case would be a higher demand using the nutrients, and then that's an insufficiency. You don't have enough for the body's needs, okay? Now, hemolysis is actually, we're going to dive into that a lot more when we get back into, or when we move back into reviewing the CMP. That's going to be the comprehensive metabolic panel, because that's going to have your bilirubin, and that's where we're going to see if a bleed in the body is changing those factors. So right now, I want you to just understand that the hemolytic anemias are coming from blood loss because the red blood cells are being broken down outside of the spleen. Remember, the senescent red blood cell, that's that red blood cell at about that 100 to 120 day life cycle, it starts to shrink. It gets smaller. It loses some of its content. It loses its flexibility. That's a signal as it's passing through the systemic circulation to the macrophages in the spleen that it's time to engulf them. And that does not include cellular content spillover in the periphery. That's the difference with the hemolytic. A hemolytic anemia could be at hitting a valve in the blood vessels from like a synthetic heart replacement or artery balloon thing. Angioplasty, I think is what, whatever they do when they put the stent. Almost always that destroys your red blood cells. So anybody that has had a valve replacement, they are very prevalent to having a high anemia onset. So we have to be watching that. The gastric bleeds, your chronic NSAID takers, your peptic ulcers, those are your other ones, or your ulcerative colitis. So when we are thinking about the nutritional deficiencies, we have to be remembering that we need to be able to digest them, right? So if we're going to be looking at where do we get the precursors for not just your red blood cell, but also for your heme? You can't make a red blood cell if you can't make a heme. Where are you going to put your iron if you can't make a heme? Heme is the precursor to a hemoglobin, right? Heme is synthesized first with your succinyl-CoA and your glycine. Then you also need to remember where succinyl-CoA comes from. Succinyl-CoA comes from methionine, the 2 branch chain amino acids, isoleucine and valine, and then also threonine. Now, you need to be able to break down the amino acids, so that's catabolism. Catabolism, first step, requires a B6, and that's going to remove the amino group, and then the rest of the molecule, which is the keto acid, can then be acted on. We're going to learn that. Oh, nope, never mind. Diet nutrition is learning that. Now I'm just telling you that you need B6 in order for that step. Then when you have your branch chain isoleucine and valine, one of the further down steps, at the very end, right when the succinyl-CoA is being generated, that is an adenylyl B12 dependent enzyme reaction. So there's only 2 forms of active B12 in your body. That's your methionine synthase cycle, which is your methyl B12. That cobalamin is part of the methionine synthase enzyme itself. Okay. Then you also have your adenylyl B12, which is this pathway for generating succinyl-CoA from the branch chain catabolism. So I want you to know that for heme, you have to be thinking, does a person eat heme? Does that mean they are eating red meat? Are they eating meat? Okay, red meat. But if you eat it and you take an antacid, or you have a history of GERD and proton pump inhibitors, then you're not digesting it. So you have to be able to digest it in addition to absorbing it. You can eat it. Did you digest it? You have to break it out of the food matrix, and your chronic antacid eaters are one problem, and then your population of vegans who don't eat meat are the other population. So my recommendation for both of those populations, as well as us normal healthy people who don't have problems with acid or not eating meat, we should supplement with a lozenge. A methyl B9, a methyl B12, and a B6 lozenge is probably one of the best ways you can go to ensure that those systems are being satisfied. So in addition to the heme synthesis, you definitely need to understand that folate as tetrahydrofolate, folate is B9, first go B9 becomes dihydrofolate becomes tetrahydrofolate. Your THF is the primary active form of folate in the body, and it goes through lots of different reactions. And the reason this is super important, and it's the intersection of why thymidine nucleic acid synthesis inhibition from deficient B9 and B12 can also impact the homocysteine pathways, is because the tetrahydrofolate right here, this 5,10-methylene, is that wasn't what I wanted, right here. This is the molecule that can either go into methyl tetrahydrofolate reductase, which is an irreversible pathway that puts a methyl group onto B9. The methyl B9 then transfers it to the cobalamin in the methionine synthase, which then puts that methyl group onto homocysteine to recycle homocysteine out of the blood for homeostasis, but it also regenerates methionine. And then one more step, that methionine, which just came from healthy methyl B9, methyl B12, methyl transfer to homocysteine to regenerate the methionine, that takes one more step, and then that's the body's pathway of synthesizing the universal methyl donor, which is SAMe. SAMe is S-adenosyl methionine. That keeps your body from developing cancers at the epigenetic level of methylation and quiescence of the genes that don't need to be expressed. It also is vital for several synthesis pathways, as well as your mood, depression, and anxiety pathways. People that cannot methylate and are deficient in SAMe because of methyl B9 and methyl B12 or B9 B12 deficiencies, they have mood, anxiety, and depression problems. Okay, so it is really important. So your 5,10-methylene will get acted on by your methyl tetrahydrofolate. However, it is also the direct it is the form of tetrahydrofolate that is going to allow for the nucleic acid synthesis into thymidine. So if you don't have enough B9, you cannot have the 5,10-methylene to synthesize thymidine. If you don't have enough B12, then your methyl irreversible pathway, methyl tetrahydrofolate, that is going to get trapped. That's your methyl trap. If you can't get B12 to take the methyl and transfer it to homocysteine, then you cannot regenerate tetrahydrofolate to go back to being able to be available to be made back into this form for thymidine. So that's how the pathways kind of intersect, and that's really important. Okay, you can read all of these. So if you pay attention here, right, this is where the methyl group here is going to move. Right? It's transferred, and then once it moves from methionine synthase, it goes on to homocysteine, and now methionine has the methyl group. Methionine goes through one more step, and that's when you get your SAMe. That's your S-adenyl methionine. Okay, that is my battery about to die, so we're going to hustle through so I don't lose you. Okay, so the transsulfuration pathway is going to be where your here, that's your homocysteine requiring B6 to make cysteine, and then cysteine is your precursor for your glutathione. Okay, so be sure you're remembering your the white blood cell patterns for your neutrophils and leukocytes, right? We want to make sure that you're looking at either the extremes, or if the lymphocyte is greater than the neutrophil, which is a chronic viral. We also want to make sure that your ESR and your CRP are being thought of. And remember that your iron is going to be a pro-oxidant, and that lead will inhibit the ability of heme synthesis. And lead can also become a problem when it's circulating in like a premenopausal or vitamin D deficiency state, where sequestered lead from bone will be released as bone is degraded if it's done too fast. And that can actually present as a new lead toxicity. All right, so I'm going to escape here. Let's find you down here. That's not it. Where is my panocto? There we are. All right, well, good luck, and I will see you next week. All right, bye.